Good evening. Last month we talked about the probe L-Cross, which landed on the moon inside the crater Cabez in the hunt for water. Well, Christmas in America, with one of the world's big telescopes, I was on the beach at Celtic Bill. Neither of us saw anything, but there have been interesting results since then.
Yes, fantastic news, in fact. So remember, L-Cross had two parts. There was the rocket that hit the bottom of Cabez, that's where most of the impact came from, and then flying a few minutes behind was the shepherding spacecraft, L-Cross itself. And we've just had the first proper results from that spacecraft, which flew through the debris that was thrown up by the rocket impact. And the good news is that NASA got what they were hoping for, what I know you were sceptical about, which is the definitive sign of water at the bottom of Cabez.
I'm afraid I'm much less excited than you are. Certainly tiny icy particles, almost certainly dumped there by a comet. That is not lunar water. The moon is as dry as a bone.
Well, it's true that this isn't anything to do with the formation of the moon, but what we have is a deposit of water on the moon. Now, it's clear that this isn't liquid water. There's no way you and I are going swimming in the bottom of Cabez anytime soon, but there must have been ice down there, and quite a lot of it. In fact, about 24 gallons was detected, so that's a bathtub full. But remember, that's just from one impact and not from the whole crater. So there must be much more down there and in other similar craters down at the moon's south pole.
Well, I wonder. We must wait and see. From the moon to the sun, and a huge solar tsunami. And that must have been a spectacular thing.
Yes, it's incredible. These are results from the Stereo spacecraft. And when scientists first saw something like this, I don't think they believed it. They thought it was an instrument glitch or some sort of error. But it's true. What you see here is a large amount of material. This is a wall of material on the surface of the sun, 60,000 miles high, moving at about 500,000 miles per hour. So it's this shock wave spreading across the sun, and it's quite a dramatic, spectacular event.
And the sun was also sending out clouds of material, and there had been brilliant northern lights or aurorae. Not from England, as far as I know, certainly from places like Norway.
Yes, and speaking of aurorae, if you can't see them from down here in Selsey, we've had a spectacular view of the northern lights on Saturn from the Cassini spacecraft, which sent back this amazing video. So you're looking in visible light. This is roughly what the eye would see, although obviously enhanced. You can see the dark part of the planet there on the night side. You can see this flickering of the lights caused by the solar wind impacting Saturn's magnetic field. It's absolutely beautiful, isn't it?
It certainly is, and Cassini has certainly exceeded all expectations. For example, Enceladus, with fountains of water ice coming from its poles, they simply shouldn't be there.
Yes, these fountains have been keeping us entertained ever since they were discovered right at the beginning of Cassini's mission. But these new images from Cassini show exactly what's going on. They're absolutely stunning. Not only can we see the vents which shoot out this water. We see these dramatic images of the stream silhouetted against the sunlight there. But if you look right down, we can see the areas from which the water's coming. You've got this very complicated landscape with all sorts of ice features and cracks, and it looks like a very dynamic and active place, don't you think?
And it's a tiny place too. And there's much more water there than there is on the moon.
Certainly, I agree with that, Patrick. That's definitely true.
And then, of course, we have this new ring of Saturn, 8 million miles from Saturn, different from the other rings, and not visible really, invisible at all.
No, it was discovered by the Spitzer Space Telescope looking in the infrared, and as you say, it's very different. It's much thicker and much wider than the other rings, made of darker material, definitely. That's why it was only discovered in the infrared.
And very, very verifiable. It solves one major problem. The problem of the satellite Iapetus, much closer into Saturn, half bright and half dark. Why was that so? We've never known. Well, now we do. The ring particles are wafted in from the Phoebe ring onto Iapetus, and the ring particles are going around in a retrograde or wrong way direction. Iapetus not, therefore they meet head on.
It ploughs straight through them. That's certainly the most convincing explanation for Iapetus's dark side that I've heard. Of course, we've still got to explain why it has this amazing ridge round the centre. It has this enormous wrinkle. That's still a mystery.
It's a weird world. Now let's come much closer in, shall we, to the planet Mars. The two rovers, Spirit and Opportunity, have been doing wonders, and very sadly, Spirit is now in trouble.
Well, Spirit's been stuck since April, in fact. It ran over a dust-covered crater and has sunk down into the soil. It's had a lot of trouble trying to extract itself. However, the team have begun efforts to try and extract Spirit from the trap that it's got itself into.
So far they had no luck, but we hope they will. Opportunity, of course, is going strong. So certainly both these rovers have lasted for far longer than their makers dared to hope. They're quite incredible things.
They are, and Spirit has moved a few centimetres in the last few weeks, so they're beginning to edge it out of the trap. I'm not ready to write its obituary just yet.
No, nor am I, and I hope we don't have to. Now this programme's called The Winter Sky, and certainly the stars of winter are more brilliant than those at any other time of the year. So let's now join peace in the garden.
I love the December night sky, and the reason for this is that it gives such a long period of darkness. Go out early evening, look up, and there are the stars of autumn shining down on you. Go out in the early morning, and there are the stars of spring shining down on you. But right in the middle of the night, that's when things get truly spectacular, because that's when the winter constellations are seen at their best. Now, winter for me means Orion the Hunter, a very distinctive pattern of 7 bright stars. You can find Orion rising in the east at about 7 o'clock mid-month. But if you give him a few hours to get up a bit higher, then we can use him to best effect. Now, Orion is formed by 2 stars at the top, 2 stars at the bottom, and 3 stars in the centre, which form a very distinctive straight line. The star in the upper left corner of Orion is orangey in colour. This is a star known as Betelgeuse, and it's a red supergiant star, a truly massive star, about 800 times the diameter of our own sun. Now contrast it with the star in the lower right corner of Orion, which is known as Rigel. This is a blue supergiant star, and when you look between them in the night sky, you can definitely see there is a colour shift. Okay. So if we go right into the centre of the constellation, that's where we have this very famous straight line known as Orion's belt. Now if you look at Orion's belt, say with a pair of binoculars, you'll see that there are lots of faint stars around it. And this is because the Orion's belt marks the direction of an open cluster of stars known as Colander 70. Now, no self-respecting hunter should be seen without a sword, and Orion is no exception. If you look below Orion's belt, you can see a faint line of stars hanging down, and this forms his sword. Now look at this region with a pair of binoculars or through a small telescope, and you can see there is an area of gas and dust there which is glowing, beautiful swirling clouds. Now this is known as the Orion Nebula, and it's a region where stars are literally being born. The hot young cluster stars in the centre of this nebula actually cause the gases of the nebula to become excited, and that's what we can see. Now Orion is a fantastic winter signpost to some of the other constellations on view. If you follow the belt stars up and to the right, you eventually come to a fairly brightish orange coloured star known as Aldebaran. Now the name Aldebaran literally means Eye of the Bull, and that's a bit of a clue to which constellation the star lies in. This is the brightest star in the constellation of Taurus the Bull, and to find the bull's face, if you look to the right of Aldebaran, you can see there is a V-shaped cluster of stars known as the Hyades. Now if you follow the belt star of Orion up through Aldebaran and keep going, curving it slightly as you go, you finally arrive at another very distinctive cluster known as the Pleiades or Seven Sisters. With the naked eye, if you get a really clear dark sky, have a look at them and see how many stars you can count there. You might be surprised. Now if we return to Orion, we can follow the belt stars in the opposite direction down and to the left. If we do this, we come to a very bright star known as Sirius, the dog star. In fact, this is the brightest star in the entire night sky. It's also the brightest star in the constellation of Canis Major, the Great Dog. Now from the UK, Sirius doesn't get very high above our horizon, and its light therefore has to pass through some rather thick and turbulent layers of atmosphere. As it does this, the star appears to twinkle quite violently, and you often get flashes of red and blue coloration with it. It's quite beautiful to watch.